Hello, let's talk about binary tree maximum path sum. So a path is a binary tree, a sequence of nodes, where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. The path sum is the path, okay, sum all the value, and then the root of binary tree, and then return the path sum of any path. So the idea is you have to go all the way to the bottom, which is your leaf, and go all the way to the top. And you have to know like when you go all the way to the top, you can only pick the maximum value. But when you go to your parent, you just have to know you have to add up every value together from your children so you can know your current maximum. So without too much talking, let me just start coding and note that the value can be less than 0. So let me say in maximum equal to, since the value can be less than 0, right? So I cannot say equal to 0. I have to say integer dot mean value. So when I updating my max, then I can actually know what I have to return. So I have to create a helper function using a depth first search. So the easy way to do is using a depth first search to traverse the tree. So I'm going to say tree node equal to tree node root. I'm say depth first search root, and then I return the max right over here. So the base case for the depth first search is if root equal to null, return 0, right? This is the best case. Now we need to know how do we traverse the children. So since the function the method is in type in, so we have to say int val left val equal to maximum. So let me just finish and I will just talk about how why I did this. So when you go all the way to the bottom, right, then you need to know that if this value is actually less than 0, so this is currently 9, because when you reach the children of the leaf, it actually returns 0. So you don't go all the way to the children of the leaf. So the 9 is the stop point. So you will return the positive integer, not the negative, because we can just ignore the negative value. And if you have negative value in your tree, that will not be the best solution ever. So this is the leaf for the left valve and also the right valve. And when you do have left valve and right valve, right? And when you go to a parent, right? So this is your parent, so there will be left valve plus right valve plus your value, which is yourself. And what we need to do is we just have to update the max. So max equal to max and val, right? And oh, forgot the semicolon. Now, since this is a path, right? So we can only pick one side. So a node can only appear in a sequence at most once, right? So you have to return what your current val plus the maximum between your left val and right val. So this will be the solution, and they just run it. Okay, I do have the arrow. Okay. In right val deficit tree. Okay, I do know this is the parenthesis error. And yes, this is a little bit simple to write, but it does take a lot of time to think about it. So we pass the test and let's talk about the time and space complexity. So for the time, you do have to traverse every single node, so that'll be all the fun, right? And for the time, for the space, is constant. This is local variable, so it will cache out the garbage once you finish the program. So there will be all of 1 for the space, all of n for the time, and this question is really I mean it should be the easy one in a hard level question. And if you feel helpful, and then subscribe, like the video if you want it, leave a comment if you have any question. Alright, I will See you later. All right.